Ever wished you could automate tasks and schedule commands to run in the future without having to sit at your desk? Whether it's scheduling system maintenance, automating reports, or setting up recurring jobs, Linux has powerful tools to handle it all. In this video, we are diving into task scheduling on Red Hat Enterprise Linux. You will learn how to use the add command for one-time tasks, cron jobs for recurring automation, and even systemd timers for advanced scheduling. By the end, you will be able to set up your system to do the work for you automatically and efficiently. Ready to master automation? Let's get started. Scheduling deferred user jobs. Understanding deferred user tasks. There are occasions when you may need to execute commands at a specific future time. For example, a user might schedule a maintenance operation to run overnight, or a system administrator could set up a temporary firewall configuration with an automated rollback in 10 minutes, canceling the rollback if everything works as expected. These planned executions are referred to as deferred jobs, meaning they are scheduled for future execution. One of the most efficient ways to handle deferred tasks on Red Hat Enterprise Linux is by using the add command, which is pre-installed and enabled by default. The add package includes the attd system daemon and the commands like at and atq to interact with it. Users can schedule jobs for execution by the attd daemon using the add command. The daemon organizes jobs into 26 priority-based queues, labeled from A to Z, with jobs in later queues, Z, Y, etc., having lower system priority. Scheduling deferred jobs. To schedule a command for future execution, use the add spacetime command. The add command reads commands from standard input keyboard and executes them at the designated time. When entering commands manually, complete input using Ctrl-D on an empty line. Alternatively, you can redirect input from a script file. As you can see in the first example, this scheduled the script MyScript to run in 5 minutes, avoiding manual command input. The add command accepts natural language style time specifications for scheduling jobs. Some valid formats include now space plus 5 min for minutes, tea time tomorrow equivalent to 4 p.m., noon space plus 4 space days, 5 p.m. space August space 3 space 2025. If only a time is provided, the command runs at the next occurrence of that time. If only a date is given, execution occurs at the current time on that date. In the first example, I created a file.sh and I named it MyScript, and I added a line in that file, echo hello from my script. So when this script runs, it will print hello from my script. And I made sure that this script is executable. And writing the command add space now space plus 5 space minutes and less than sign and then the script. This command will make sure that myscript.sh will run after 5 minutes from the time we ran the command. To schedule a job to run in 2 minutes from now, save the output of the date command to the /home/user/myjob.txt file. Pass the date greater than /home/user/myjob.txt string as the input to the add command, so that the job runs in 2 minutes from now. To interactively schedule a job in the G queue that runs at tea time 4 p.m., the job should print the its tea time message to the /home/user/t.txt file and append the new messages to the /home/user/t t.text file. To inspect the details of a scheduled job, use @c space and the job number. View and manage deferred jobs. To see a list of all pending jobs for the current user, use the atq or @q command. Each line represents a scheduled job with a unique job ID 1, 2, 3, the execution date and time, the queue, A, etc., where A is the default, the username of the job owner. Note here, unprivileged users can only manage their own jobs, while the root user has control over all jobs on the system. As we said before, to inspect the details of a scheduled job, use at command space -c small space and the job number. This displays the job's execution environment and commands. To remove a scheduled job, use the atrm for @remove command. The command is atrm space and the job number. For instance, if a remote firewall configuration succeeds and no rollback is needed, the associated scheduled job should be removed to prevent unnecessary changes. By understanding and using the @, command effectively, you can efficiently schedule and manage future tasks, automating various system operations with precision. Scheduling recurring user jobs. Recurring jobs are tasks that run repeatedly at predefined times. On Red Hat Enterprise Linux, the Cron daemon, which is active by default, manages these scheduled jobs. The daemon reads scheduling instructions from user-specific cron tab files and system-wide configuration files. Users can modify their personal cron tab using the cron tab space -e command. If a scheduled job generates output and redirection is not specified, cron D will send the output via email to the job owner. Setting up recurring jobs. The cron tab command is used to create, modify, and manage scheduled jobs. If you run cron tab space -h, you will see a short help for the command. Cron tab space -l displays the current user's scheduled jobs. Cron tab space -r removes all scheduled jobs for the user. Cron tab space -e opens the cron tab file for editing. If cron tab space and we specify a file name, replaces all existing jobs with those from a specified file. If no file is provided, input is read from standard input. Administrators can use the -u option to manage jobs for other users. However, using cron tab at the root user is discouraged for security reasons. Privileged jobs should be managed differently, as explained in system job scheduling sections. When editing the cron tab file with cron tab -e, the default editor is vim, unless another editor is set via the editor environment variable. Each job occupies a separate line in the file. Recommended formatting includes empty lines to improve readability, comments indicated by hash to provide description, environment variables written as name equal value, and the variable name all in capital letters to configure settings affecting all subsequent jobs. Common variables include shell, specifies the shell interpreter. Mail to determines the email recipient for job output. An important note here, sending email notifications requires additional system configuration, such as setting up an SMTP relay or local mail service. Cron tab time and date format. A cron tab entry consists of 5 scheduling fields followed by the command to execute: minute, hour, day of month, day of week, and the command. Scheduling rules: *, execute the job for all possible values of the field. x-y runs the job within a specified range of values. X, y executes the job for multiply specified values. Asterisk over x runs the job at intervals of x. X and y here refer to numbers, can be hour or minute. And we have days of the week represented numerically. 0 equals Sunday, 1 Monday, and so on, with 7 also considered Sunday. Months and days of the week can also be specified using 3-letter abbreviations, like Jan for January, Feb for February, MON for Monday, and so on. Commands containing percentage sign must escape it or use it as a new line separator for input redirection. Examples of recurring jobs. The first one, annual backup job, runs /usr/local/bin/yearly_backup script at 9 a.m. on February 3rd every year. The second one, hourly notification on Fridays in July, sends an email with chime every 5 minutes between 9 a.m. and 4:55 p.m. on Fridays in July. Last one, automated email check-in, sends an email with the subject checking in to developer@example.com at 9 a.m. on weekdays. Automating recurring system tasks. System administrators frequently need to automate tasks that run on a regular schedule. It is generally recommended to execute these tasks from system accounts instead of individual user accounts. Rather than using the cron tab command for scheduling, administrators should utilize system-wide cron tab files, which include an additional field specifying the user who will execute the job. The /etc/crontab file includes a syntax guide within its comments, as shown. To maintain system integrity, always place custom crontab files in the /etc/cron.d directory, instead of modifying /etc/crontab, preventing potential overwrites from package updates. Software packages that require scheduled tasks also store their cron files in this directory, allowing administrators to group related jobs. Besides individual cron tab files, the cron system provides designated directories for scripts that need to run at predefined intervals. /etc/cron.hourly runs hourly jobs. /etc/cron.daily runs daily jobs. /etc/cron.weekly runs weekly jobs. /etc/cron.monthly runs monthly jobs. These directories contain shell scripts rather than cron tab files. Ensure scripts are executable by running chmod +x space and the script name. Running periodic commands with Anacron. Anacron is designed to guarantee that scheduled jobs execute even if the system was powered off during the intended runtime. It reads from the /etc/anacron tab file, which defines delayed execution parameters. When a job cannot run at the scheduled time, it will execute upon system startup. The syntax of /etc/anacron tab, each line consists of 4 fields. 1. Period in days, specifies how often the job should run. For example, at daily for every day, at weekly for every week. 2. Delay in minutes, defines the wait time before execution. 3. Job identifier, a label for logging purposes. 4. Command, the script or command to execute. Anacron maintains timestamps in /var/spool/anacron, allowing administrators to verify when jobs were last executed. The start_hours_range variable in /etc/anacron tab ensures jobs only run within a specified time window. Automating tasks with systemd timers. Systemd provides timer units that activate corresponding service units based on predefined schedules. These timers log execution events for easier troubleshooting. For example, systemd timer unit. The sysstat-collect.timer unit runs every 10 minutes to gather system statistics. Its configuration file /usr/lib/systemd/system/sysstat-collect.timer. Systemd timers support complex schedule. For example, this runs the associated service at 12:35 60 seconds and 12:37 16 and 12:39 16 every day in June 2025. Alternatively, relative scheduling can be used. This triggers the service 15 minutes after the last execution. Best practices for systemd timer management: avoid modifying system timer files in /usr/lib/systemd/system. Instead, copy them to the /etc/systemd/system and make changes there. If duplicate names exist in both locations, systemd prioritizes the version in the /etc/systemd/system. After modifying a timer unit, reload the daemon to apply changes by running the command system-control -daemon-reload. You can enable and start the timer using system-control -enable --now unitname.timer. For further details, consult the following man pages: Cron tab, Anacron, Anacron tab, systemd.time, systemd.timer, and cron-d. Managing temporary files in Linux. Efficient management of temporary files is crucial for maintaining system performance and preventing disk space issues. This section covers how to enable and disable systemd timers and configure a timer to handle temporary files. Understanding temporary files. Applications and services use temporary directories like /temp for transient data. Some applications store temporary data in volatile directories under /run, which exist only in memory and are self-cleaning upon system reboot. Properly managing temporary files prevents issues like excessive disk usage or missing files required by daemons and scripts. Using systemd-temp files tool for temporary file management. Red Hat Enterprise Linux provides the systemd-temp files tool to manage temporary files and directories systematically. At system boot, the systemd-temp files-setup service executes systemd-temp files -create or -remove command, reading instructions from configuration files located in /usr/lib/tempfiles.d, /run/tempfiles.d, and /etc/tempfiles.d. And as you can see, the first one, /usr/lib/tempfiles.d, contain 129 configuration files. These configuration files dictate which files and directories should be created, deleted, or secured. Automated cleanup with systemd timers. To prevent disks from filling up with all temporary data, the systemd-temp files-clean.timer unit automatically triggers the systemd-temp files-clean.service, executing systemd-temp files --clean command. The timer configuration includes on boot second equal 15 minutes, runs 15 minutes after system boot. On unit active second equal 1 day, repeats every 24 hours. Modifying the timer settings allows customization. For example, running cleanup every 30 minutes. Reload systemd after changes with system control daemon-reload. Manual cleanup of temporary files. The command systemd-temp files --clean removes files that haven't been accessed, changed, or modified within the configured time limit. Configuration files define cleanup rules using syntax that includes: first, type. Example, D small for directory creation, D capital for directory cleanup. And then path, location of the file directory. Last, permissions, mode, ownership, and age settings. Configuration file precedence. The system prioritizes configuration files in this order: 1/etc/temp-files.d, highest priority used for custom configurations; 2/run/temp-files.d, used by daemons for runtime files; 3/usr/lib/temp-files.d, vendor provided defaults should not be modified. To override vendor settings, copy the necessary file to /etc/temp-files.d and modify it. When testing configurations, apply commands from one file at a time. To apply changes for a specific configuration file, for example, systemd-temp-files --clean and the path of the configuration file. For more details, refer to the systemd-temp-files, temp-files.d, and systemd.timer manual pages. And that's it. Now you know how to schedule future tasks like a pro on Red Hat Enterprise Linux. Whether you are using AT for one-time jobs, Cron for recurring tasks, or systemd timers for advanced scheduling, you have the tools to automate your workflow and save time. Now it's your turn. Try scheduling a task on your own system and let me know in the comments how it went. Have any questions? Drop them below. I'm here to help. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you never miss a Linux tutorial. More powerful sysadmin tips are on the way. Thanks for watching, and I will see you in the next video.